So we had introduced lines and equations of lines. We had seen what an equation of a line is. So I sent you some numbers to find out or to find equations of a line. And to start with, if you recall, we talked about equations of a line, and we saw that a line can be got using the following techniques. One of the techniques we saw was using the equation of a line, which is y is equal to mx plus c. The other one was using y minus y1 out of x minus x1, a known point, is equal to the gradient m, the line. Now it is from here that we can go ahead and identify other items. For example, we can talk about the collinearity or collinear points. Collinear points. If points are collinear, what do we think about them? We should think about them as points that lie on the same straight line. That's why you hear the word collinear. So therefore, if A, which is small ab, and B, which is small cd, and capital C, which is small e, f, lie in a straight line or lie on a straight line, then they are said to be collinear points. They are said to be collinear points. Therefore, if they lie on a straight line, then the gradients of the line joining, AB is equal to the gradient of the line joining BC. Whereby if this is our line, and according to this line, we have the following. We have a point here, A. We have a point here, B. Then we have a point here, what? C. Then the gradient of AB, which is maybe M1, the gradient of BC, which is maybe M2, these two gradients should be the same. So grad of AB should be equal to gradient of BC. Now the gradient of AB, remember A is small a, B, small c, d, small e, f. So gradient AB will be d minus b out of c minus a. Should be equal to the gradient of f minus d out of e minus c. If you confirm that, then these points are collinear. So with that definition, you can have an example. Show that the points A, 2, -4, B, 5, 0, C, C and C, 8, 4 are collinear. So you choose the gradient of any two of them, it should be the same. So if they are to be collinear, we are asking you to show that they lie on the same straight what? They lie on the same straight line. So we are expecting you to be in position to identify A, to identify B, to identify C, where A is 2, negative 4, B is 5, 0, C is 8, 4. So the gradient of AB can be attained. Gradient of AB is going to be equal to change in y, which is going to be 0 minus negative 4, divided by change in x, which is 5 minus 2. And this is 4 out of 3. Then investigate the gradient of BC. Gradient of BC is going to be equal to, BC can be attained from change in y, which is 4 minus 0, divided by 8 minus 5. The answer is also 4 out of 3. Roman 2. So Roman 1 and Roman 2 are the same. So since the gradient of A, B, and BC is the same, hence that has shown that they are collinear. So points that lie on the same straight line have the same gradients if you've taken any 2 points along that line. Okay. There's another method we can use to confirm this. There is what we call the vectorial approach. For the vectorial approach, you get vector OA in vector form and have it as 2, negative 4. Then get vector OB in vector form, position vector OB, which is 5, 0. Get position vector OC, which is going to be 8, 4. Now, for collinearity, the vector AB is supposed to be equal to OB minus OA, which will give us 5, 0 minus 2, negative 4. And this gives us 3, 4. Whereas if I'm to get BC, BC can be got from OC minus OB. So you can show collinearity using the equations of a line, using gradients, then vectors, you show that they have the same direction vector if they are on the same line. So OC is going to be 8, 4 minus 5, 0. This will give us 3, 4. So you see that the direction vector of AB is actually the same as that one of BC. And it has a coefficient 1, whereby it says that if a vector is A and is equal to a scalar multiplier of B, then this is showing that these vectors, 1, are parallel, 2, they are collinear. So the collinearity condition can be displayed using this definition in vectors. So because this one and this one are the same, so the constant k is 1, so it means this can also show that the points A, B, C are collinear. So there you are using the method of vectorial approach. So I'm going to ask you to show me this, whether these numbers are, these points are collinear. Try this activity out. If points -2, -3, 3, 5, and 13 P are collinear, find the values of P. Try that one out very fast. Investigate that question. Then I bring another definition. You have an answer, you let me know. Correct. Thank you. Hope everyone's getting 21. You two, have you got 21? Master, did you get 21? Is my man Sware here? Sware?
Yes, yeah.
Did you get 21? Guys, anyone who's not gotten 21? You have not got 21, please let us know. Otherwise, we are good to go and introduce this definition. So, if we don't have a challenge with getting 21, it can be asked to find the midpoint of a line. So if we consider 2 points that are joining that line, maybe those points are P and Q, are the main points that join the line, by saying consider the line joining 2 points.
So I missed.
Yeah?
So may you take back to the first page? I missed it.
Okay. Screenshot, eh?
Yes. Excuse me, sir.
Yes, please.
So may you please summarize? I joined late.
Hey, you didn't hear what I said, what I told?
Yes.
Where exactly? In the second method, the first
Points.
method? Eh?
Collinear points.
Collinearity of points, we said, if points lie on the same straight line, then the
Yes.
gradient of AB is supposed to be equal to the gradient of BC. And what does that mean? It means that if you are here between A and B, and you get the gradient of this part, that gradient should be the same as the gradient of this part. It is also the same as the gradient from A up to C. So any gradient you choose to find should be the what? The same. So we said now, if I get the gradient of AB, it is going to be 0. Gradient of AB would be 0 minus -4, which gave us that, as in change in y, over change in x, which is 5 minus 2, so we came up with 4/3. For BC, I used the 4 minus 0 as change in y, and change in x was 8 minus 5, which is also 3, so this confirmed that they have the same gradient, hence they lie on the same straight line, hence they are collinear points. So they said also we have method 2. Method 2 is to use vectorial approach. When you use the vectorial approach, in vectors, we say they have the same direction vector if they lie on the same straight line. The same direction vector, or we can say one vector is a scalar multiplier of another. Now, I decided to estimate the vectors as OA, which are position vectors, OB as that. Then I got vector AB. Vector AB is from A to B, which is OB minus OA. It gave us 3, 4. Consequently, we got vector BC. BC is going to be OC minus OB, which is also 3, 4. Even if you use CB, even if you use BA, you'll get negatives. Those negatives will be accounted for by this constant K. But if you choose the same direction, AB, BC, then you get both of them positives, and thus you'll see that AB is a scalar multiplier of BC, but the scalar multiplier this time around it is 1. So the definition using vectors is as this one. If one vector is a scalar multiplier of the other, 1, it shows that they are parallel. 2, it also shows in vectors that they are collinear. So we have used both methods for collinearity, which include 1, the gradient method, and then 2, the method of parallel vectors, one being a scalar multiplier of another. Okay, are we good now?
Yes, teacher.
So we are going for what next? We are going for midpoint of a straight line. And I was saying, if you consider a line joining 2 points P, which is x1, y1, and Q, which is x2, y2, and M is the midpoint of that line, yeah, then you would see that if M is the coordinates of the midpoint of the segment using the lines P, the points P and Q, then we can clearly see the following. That 1, if I'm here at A, yeah, then A minus x1 gives us the, if this is going to be the midpoint, you should see that 1, let me show you this. You know, I have to derive it in A level, we derive. The gap here should be equal to the gap there if they are midpoints. Likewise, the gap here should be equal to the gap where? There. Okay? So in that sense, this is what we expect. The difference between this gap is actually B minus Y1, whereas this one is Y2 minus B. We agree? Whereas here it will be A minus X1, whereas this one is going to be X2 minus A. But they are equal. So if M of coordinates AB is the midpoint of PQ, then the segments A minus X1 is equal to X2 minus A. So this will give us 2A is equal to X1 plus X2. Can you see that A becomes X1 plus X2 out of 2? So if you have always been cramming in your primary, this is the reason why we say that the midpoint is always the sum of the X values divided by 2. Go to the Y. Vertical segments, we shall have Y2 minus B is equal to B minus Y1. So Y2 plus Y1 is equal to 2B. Therefore, B is equal to Y1 plus Y2 divided by 2. In that sense, the midpoint M becomes X1 plus X2 out of 2 and Y1 plus Y2 out of 2. Hence, this is how the expression of the midpoint of the line can be realized. Okay? I think you've already seen that equation, but you don't know how it comes about. So let's have a simple example on this, because you see how brief it is, it can easily be handled. Example, find the coordinates of the midpoint of the line joining A 3, 2 and B 5, 4. Okay, so straight away, they're asking you to, if this is the straight line, having what? Point A and a point B. This is 3, 2, this is 5, 4. So M would become what? X1 plus X2 out of 2, Y1 plus Y2 out of 2. Then M into brackets will become 5 plus 3 divided by 2 and 4 plus 2 divided by 2. Our midpoint M will become 4, 3. So you don't need to write this formula if you already know it, because in pure math, I told you formula don't carry marks in math. We assume you know the formula. So the midpoint is 4, 3. Hence, that is the solution. Okay. Another definition we have to look at today also is the distance between 2 points. So next definition is distance between 2 points. If we finish this week, you try to check on my YouTube channel all through. I'll be posting other videos that will come ahead. This is distance between 2 points.
Sir, can they ask you to derive those equations?
Nah, but we need to know where they come from. The reason why we get to know where they come from, in case you get stuck and you're not sure of the equation, you can always go back from basics. From first, you see we do things from first principles. So you can always go back to first principles if you are not certain of what you have realized. So I have this as my y-axis. I have this as my x-axis. I have this as my line. And I would wish to get points. I have this point P. I have this point Q. And according to these points, we have here y1, we have here y2. Then we have here x1. Then we have here x2. If this is forming a right angled triangle, as you can see, then at this point where we have P has x1, y1. Then Q here has x2, y2. So if this is point R, then if I consider triangle PQR, yeah, it is a right angled what? Triangle. If I want to get distance PQ squared, will give me PR squared plus QR squared. So it is from here that one can see the following. One can realize that actually this distance here, this distance here is x2 minus x1. Whereas this one here is y2 minus y1. So those are the distances one is expecting to deal with. So if those are our distances, then we are going to expect the following. We shall expect P2 is the distance we are looking for. Is going to be equal to x2 minus x1 squared plus y2 minus y1 squared. So at the end of the day, P2 can be got from the square root of x2 minus x1 squared plus y2 minus y1 squared. Hence, that is the formula for the definition of distance between 2 points. So with that formula, everyone knows it from primary. So if I look at an example, though here at advanced level, we need to know how it comes about. You can say find the length. Find the length of a straight line. Find the length of a straight line joining the following pairs. Joining the following pairs of points. A, 3, 2, and B, 8, 4. B, P, negative 1, 3, and Q, 4, 7. The first one is for the teacher, the second one is for the learners. So A, the solution of A is going to be AB is the distance, so it's going to be got from the square root of x1 minus x2 squared plus y1 minus y2 squared. The order does not matter because you square them at the end of the day. So we shall have the square root of 3 minus 8 squared plus 2 minus 4 squared. Then we shall get 25 plus 4 under the square root. Hence, the answer is root of 29. We say 29 what? Units. So can you find for me the second one? You should also follow my TikTok account. It's at Hamza Rubama. So I also put there some short videos of these courses. So some 5 minutes of a concept. You can also have them. There's another YouTube channel which I've designed also for the very short courses, for the very short presentations. It is called Simply Learning. So when you go to YouTube also, you can search for Simply Learning and you'll see those short videos of concepts I've defined. So as you write down that, let me have my heading, intersection of the line and the line, or a line and a curve.
Excuse me, sir.
Yes, please.
Sir, may you please take back the second page?
Okay. This one.
Yes. Sir, so that activity of collinear isn't P9.
P, no. P was 20 what? 21. What did we get? P is 21. The answer here is what? 21. So I'm waiting for that answer.
41 units.
Eh?
41 units.
What you eh?
Square root of 41.
A square root of 41 units. I heard as if you're just saying 41. It is square root of 41 units. So if we have a point of intersection of a line and a line, or a line and a curve, then that point of intersection should or must be satisfying the equation of the lines you have or the equation of the curve that you have at the same time. So to obtain that point of intersection, the equations must be solved simultaneously. Okay, so examples. Find the point of intersection. Find the point of intersection of the following given lines. A, 2x minus 3y is equal to 6, and 4x plus y is equal to 5. So to solve simultaneously, we have 4x plus y is equal to 5. We have 2x minus 3y is equal to 6. We can eliminate by multiplying this by 2, and we subtract. We shall get 0 for x. Then this will give us a positive 6 plus 1, giving us 7y. Gives us what? Yeah, 7y. It gives us 7y. It's going to be equal to negative 12. Negative 12 plus 5. Negative 12 plus 5, you get a negative 7. Therefore, y is equal to negative 1. If y is equal to negative 1, substitute in n of the equations to get x, you'll get 4x minus 1 is equal to 5. So 4x is equal to 6 divided by 4 divided by 4. X becomes 3 out of 2. So therefore, we have the point of intersection as 3 out of 2 and negative 1. That is our solution. So with that, we have solved simultaneously the line.
Repeat.
I'm solving using simultaneous equations of senior 2, which we also saw in algebra earlier on. And I'm saying because the lines are intersecting, if the lines are intersecting, we expect them to intersect at a point. So this point of intersection should satisfy this line, should also satisfy that line. So as they are solving simultaneously, we solve them, you can use substitution, you can use elimination. So me, I've used elimination by multiplying this second equation. This is equation 1, this is equation 2. I've multiplied equation 2 by 2 and subtracted to eliminate x. So I got here negative 4x. 4x minus 4x, I got a 0. Negative 2 came and multiplied the 3y, it gave us a positive 6y, plus y, a 7y. The negative 2 multiplied the 6 gave us a negative 12, plus 5, a negative 7. That is how I've realized y is negative 1. And after realizing y is negative 1, go ahead and investigate other items and see how you can have the value of x also obtained. Okay. So with that note, let me do one for a curve. Find the point of intersection of the curves and lines below. So I'm doing 1, you'll do the rest. Y is equal to x squared plus 1, and y minus x is equal to 1. 2, y is equal to 12x squared plus x minus 6, and y is equal to 0. 3, x minus y is equal to 6, and y squared is equal to 8x. Let me do the third one. You will do the rest. We are seeing that x minus y is equal to 6. We also have y squared is equal to 8x. I can substitute either for y here or for x there. So I can make here x the subject to become 6 plus y. So I drop this 6 plus y where I have what? X. So I'm substituting. Y squared will give me 8 brackets 6 plus y. So we shall have y squared minus 8y minus 48 is equal to 0. Then we solve the quadratic equation, meaning the curve is going to be touched either by 2 points. If it touches it by a repeated point, if the point is repeated, remember repeated roots, then it means it is 1 point which touches the curve. But if it gives 2 values, it means the curve is being cut through by that line. So when you compute what you get, 2 numbers multiplied, you get 8. Added, you get negative 48. When you multiply them, you get negative 48. When you add them, you get 8. That is negative 12 and 4. So y squared minus 12y plus 4y minus 48 is 0. So we have y into y minus 12 plus 4 into y minus 12 is equal to 0. Y minus 12 and y plus 4 is 0. So we have y is equal to negative 4 and y is equal to positive 12. So it means the curve is being cut at 2 points by the line. So get the corresponding x values. The corresponding x values are x is equal to 6 minus 4, which is 2. Also x is equal to 6 plus 12, which is 18. Therefore, we shall have 2, negative 4 is a point of intersection of a line and a curve. Another one is 12, positive 18. I've told you this means that if our curve, for example, this curve is y squared is equal to 4ax, this curve is a parabola, and it looks like this. Let me show you how it looks like. So if this is then our parabola looks like this. You'll study these items later in future. So it means the curve is cutting the parabola. For example, like that. Even if it's not exact, but I'm just trying to show you that it's cutting it at 2 points. If it was 1 point, it would just be a tangent, so it would be touching. For a curve, yeah, or it can cut it even once. It can touch as a tangent, it can cut as 1 point, it can cut at 2 points. Okay, so we can have that sketch down, then the rest you investigate them in your free time. So as time is flying out, I wanted to also give you the definition for parallel lines and perpendicular lines, so that we can at least have that also sorted. The rest of the items, perpendicular distances, those ones will visit my YouTube channel. I'll write them, I write and send the definitions. Or you visit my TikTok account. Yeah?
Some ain't comfortable with the other answer of 21.
Hey, you want me to take a look? Where is the number? Here is the number. Let me wrap this part up. You know, that's how numbers sometimes are. You know, a number is very simple. You know, you have to get the answer. Then the number mixes you by getting a wrong answer, which you're not comfortable with. So if there are points that lie on a straight line, we have point 1, -2, -3. We have point 2, 3, 5. We have point 3, which is what? 13p. If this is A, this is B, this is C, then the gradient of AB should be equal to the gradient of BC. So we shall have 5 minus -3 out of 3 minus -3 is equal to P minus 5 out of 13 minus 3. Algebra. Do you see that this becomes 8 out of 6 is equal to P minus 5 out of 10? So we shall cross multiply, but I can first divide this by 3. This gives me 5. So this gives me 40 is equal to P minus 15. 3P minus 15. So 3P is going to be equal to 55. It was what? Let me check whether I wrote it correct. The person who got to
3 minus -2.
Down, eh?
Yes.
Okay, so it is -2 here, giving us a 5, eh? Not so. It gives us a 5. By 5 here, it gives me a 2. By 5 here once. So you cross multiply, we shall get 16. The rest that fall are wrong. So we shall get here 16 is equal to P minus 5. P is equal to 16 plus 5. Happy?
Yes.
Okay. Yeah, that's how numbers are. There are numbers you feel like you should pass, and you see the number is misbehaving. Give it time, go over it again, go over it again. It's okay. Even if you go over it for a month, but if you get it right at the end of the day, it is very impressive. So I want to talk about the last definitions today as parallel and perpendicular. lines. Parallel and perpendicular lines. Starting with parallel lines. If you consider the graph below, whereby in this graph, we can have the following. And we have some two lines which are parallel. One of the line is that one. The other line is this one. And clearly we see that these lines are parallel to each other. Then I can have the following. One, this line can be at an angle alpha. This one can be at an angle beta. The x-axis, then this is our x-axis, then this is our y-axis. This is line 1, this is line 2. Now, you will see that the lines L1 and L2 are supposed to be inclined at the same angle to the x-axis. Therefore, if the angles of inclination to the x-axis is the same for both lines, then they are parallel. I.e., alpha should be equal to what? To beta. So therefore, if you introduce tan on both sides, introducing tan on both sides, your trig machines, you shall have tan of alpha is equal to tan of beta. But remember, the tangent of the angle of inclination to the x-axis defines the root 2. What does it define? If you have the ratio, of the angle, the ratio of the tangent of the angle of the line inclined to the x-axis, what does that define? Root 2? You remember?
Yes, teacher.
What does it define? The tangent of an angle inclined to the x-axis gives us what?
I think it gives us sine theta over cos.
That is not what I wanted. I wanted you to give me, if you recall the first definitions we had in coordinate geometry, how we form the gradient. The gradient is the slope. The slope could be formed from the ratio of the tangent of the angle of inclination. Mercy, what does it give us?
The x2 minus x1 out of y2 minus y1.
You've said it in the reverse order. It's supposed to be y1 minus y2 over x1 minus x2. But what is that? What is that you are reading?
Gradient.
It's the gradient. So it's the gradient of line 1. For example, line 1 has an angle alpha. So tan of alpha gives us the gradient of line 1, which is m1. And also tan beta is the gradient of line 2, which is m what? M2. So this is the definition for parallel lines, whereby for them, the gradient has to be the what? The same. So i.e., the gradients are the what? Are the same. So the gradient of line L1, gradient of line L1 is equal to gradient of line L2. So that is the condition for parallel lines. Okay, we have heard of it before, but you had to know as advanced mathematicians, how does it come about? It comes from that ratio of the angles because their angles of inclination are the same to the horizontal. Okay, the last definition is going to talk about perpendicular lines. How do we come about with perpendicular lines? So for perpendicular lines, perpendicular lines. So for perpendicular lines, we are going to have the following. Consider the graph below. Consider the graph below. And according to this graph, this is what we expect. So if there is a line that has been inclined at an angle alpha, then there is another line which has been inclined from this way. Therefore, we can have the following in place. We can have this as point. This is another point A. This is a point B. This is a point, I draw a perpendicular from here up to down here. I can have this as point E. Also this side it will be perpendicular. I can have this as maybe point D. This is my line 2. This is my line 1. Then the following also can be true. 1, I can have an angle here. I can call this angle theta. Then down here, I can have an angle 90 minus theta. When I call this angle alpha, then up here, I will have 90 minus alpha. Right? So with that sense, considering triangles, considering triangle ABE, ABE, you will see that alpha plus angle ABE should give us 90 degrees, plus this angle up here. Then if I consider triangle BED, that will be theta plus angle D. Okay, EDB, I'm going to get also 90 degrees. So you should also note the following. You can note that angle ABE is equal to angle BDA. And what does that mean? It means that equation 1 is equal to equation 2. So if that is the case, we shall have alpha plus angle ABE is equal to 90 degrees. Is equal to, because both of them are equal to 90, then they are equal. So it is equal to theta plus angle EDB. Now, because we have seen angle ABE is equal to angle EDB B. And these are going to be the same as 90 minus alpha or 90 minus theta. Then we shall have, because why do I say, because if I still say this is equal to 90 minus theta, n of the two, because this one was corresponding to this one, and this one was corresponding to that one. If both of them are equal, then it means 90 minus alpha is equal to 90 minus theta. And therefore, theta is equal to what? Alpha. So if theta is equal to alpha, we can now see that if you let the gradient of L1 be M1 and that of L2 be M2, then we shall have M1 is equal to tan alpha. Then M2 will be equal to, if you look at, remember we said the tangent is positive if the line is facing like L1, while the tangent is negative if the line is facing like L2. If you remember that definition also. So it means one can say the tangent of M2, the tangent of M2 is the tangent of M2 is the tangent of theta, which is going to be a negative of E of BE out of ED. And in that sense, why is my pen so sensitive? First stabilize my pen. So M2 is going to be equal to a negative BE divided by ED. So with this sense, we shall have, if one looks at it carefully and rewrites this whole expression by saying the following, that this is the same as writing it as negative BE out of BE divided by a negative ED out of BE. If I divide both of them, the upper one becomes 1 because of division. It becomes a negative 1. Therefore, M2 will become negative 1 out of ED out of what? BE. But if you look at this angle, the tangent of theta is ED out of BE. So that means M2 is going to be equal to a negative of 1 out of tan of theta. Okay? So if it is equal to negative of 1 out of tan of theta, also recall that tan theta was equal to tan what? Alpha, because those two angles were the same. So for that reason, M2 will become a negative 1 out of tan alpha, which tan alpha we have already seen is negative 1 over M what? Over M1. It is from here that M2 times M1 is always equal to a negative 1. So whoever was not comfortable with the derivation, we just need only this. But as a teacher of advanced mathematics, I had to show you how the derivation comes about, but no one can ask you to derive. Okay, so hope we don't have any questions. We have 9 minutes for some examples. So can we have that screenshot and we look at some numbers at least.
Teacher, how is angle ABE equal to BDA?
Angle
ABE equal to BDA.
Angle ABE equal to angle BDA. You're asking why is this angle at B here? Why is it equal to this angle here? Not so. Yeah. Now it is because if you look at those two angles carefully, let me extract out a triangle here. If this is alpha and this is 90, this should be 90 minus what? Alpha. First of all, these lines, when they are meeting perpendicular, they are meeting at 90 what? At 90 degrees, not so. Now, because this is 90 minus alpha already, if this one is split, and the angle down here we saw as 90 minus theta, okay? This one also will be 90 minus what? Alpha. Now, because this is 90 minus alpha, and we have also seen that this is also 90 minus alpha, hence 90 minus alpha is equal to 90 minus theta. I don't know that you've got my point. Yeah?
No.
Guys, listen to me very well. Line 1, line 2, x-axis, angle alpha. Do you agree? Let me start with alpha. Do you agree that's alpha?
Yes.
If they meet at 90, what angle is inside here? $90. Do you agree?
Yes.
What is the balance of the angle here? Yeah? What angle is here? Isn't it 90 minus alpha?
Yes.
Now, if a perpendicular is drawn from here to the x-axis, and this angle bisected here is theta, and this is 90. If this is 90, do you believe that this is also 90 minus alpha? You agree?
Yes.
Now, if this is theta, do you agree that this is going to be 90 minus theta?
Yes.
But already we had seen it is 90 minus what?
Alpha.
Hey, I hope now it's fine.
Yes. Thank you.
You're welcome. Okay, examples, guys. Find if AB is parallel or perpendicular to PQ in the following cases. A is 1, 4, B is 6, 6, P is 2, -1, 3 is 12, 3. So get AB, the gradient of AB. It will be 6 minus 4 over 6 minus 1. This is 2, this is 5. Then the gradient of PQ is going to be 3 minus 1, -1, out of 12 minus 2, giving me 4 out of 10, which is 2 out of what? 5. When gradients are the same, what do we conclude? Cynthia? Cynthia?
Yes, teacher.
When the gradients are the same, what is the condition? Are they parallel or they are perpendicular?
They are parallel.
Then line AB is parallel to PQ. Okay. Then the second question on that note is this one, part B. A is -1, -1. B is 0, 4. P is -4, 3. Q is 6, 1. Gradient of AB will be 4 minus -1 out of 0 minus -1. The answer is 5. Then gradient of PQ will give us 1 minus 3 divided by 6 minus -4. The answer is -2 out of 10, which is -1 out of 5. When I multiply, if this is M1 and this is M2, when I multiply M1 times M2, I should get -1. Because they are not the same, it confirms they are not parallel. So what do we have? They might even not have any of the two conditions. Until you prove that when you multiply them, you get -1. That's when you can conclude that, okay, maybe now they are parallel. So if I multiply and divide these two, the answer is -1. Hence, line AB and line PQ are perpendicular lines, or they meet at 90 degrees. Then sometimes also they give you equations of lines. And they ask you to do the following. Screenshot that very fast. You have 3 minutes. I'm going to send some examples here you look at, and even some more questions. Then also visit Backhouse 1. We are remaining with perpendicular distance of a line and angles between lines. Those ones I may send them later. So we can have the following example. The example says determine whether the straight line through the point, no, it says determine the equation, not whether. It says determine the equation, of the straight line passing through the point 3, -3, and is perpendicular to the line with the equation 3x minus 2y minus 6 is 0. Now, in such questions, you have to first identify the gradient of that given line by saying 2y is equal to 3x minus 6. Then y is equal to 3x minus 6 divided by 2 divided by 2. When you simplify, you'll confirm y is 3 over 2x minus 3. Compare this with mx plus c. What you want is m. So m1 is going to be 3 over 2. Now, because they have told us that the line is perpendicular to the line passing through that point, investigate using the condition for perpendicular what? Lines. So I don't know my gradient m2, but if I multiply it with m1, they should give me -1. So m2 times 3 over 2 is equal to -1. So m2 will give us -2 out of 3. With that note, I can now use any of my other techniques of y minus -3 divided by x minus 3 is giving us the gradient m2. When you cross multiply, you get 3y plus 9 is equal to -2x plus 6. So 3y plus 2x plus 3 is equal to 0 is the equation of the line. Well, we have used what technique? We have used the technique of seeing that you get the perpendicular lines condition and investigate the gradient of the second line. That second line, if you get its gradient, it passes through a point 3, -3. So you can use any of the techniques of finding equations of a line if you have one point and the gradient. Okay. So if you simplify that, it comes up to that. Another one, determine the equation of a line passing through -1, 2, and is parallel. And is parallel to the line x -y plus 2. Maria Kankwasa. Maria Kankwasa, Maria, are you there?
Yes, teacher.
What is the condition for parallel lines about their gradients? What is the condition for parallel lines? Anytime soon I'm posting your test, so be ready for it. I'm going to mix both pure and mechanics so that you have one test at once. So I think I might be ready by tomorrow or Thursday. Yes, Maria, what is the condition for parallel lines? For their gradients?
Yes, sir.
Yes, please.
Their gradient is the same.
Okay, thank you. Yes, Swale, you were asking something? Swale, did you ask something? So if you compare with these two,
May you pardon from the second gradient? M2 is equal to -2 out of 3.
and if M2 is equal to -2 out of 3, use the condition for finding the equation of the line, which says y minus y1 over x minus x1 is equal to m. This is the known point, which is this one, algebra. Or you go and use y is equal to mx plus c. Then feed in that point, get c, feed in the gradient, feed in these very known points you have. When you get c, come back and substitute c and m in that equation. I expect you to know how to deal with the equation now. Guys, there are things we have covered before, whereby when we get something new and we reach where we covered before, I expect people to be steady. Okay? So let's have this one handled. The gradient m is going to be 1 because there is a 1 here. So if the m is 1, it means also m2 is 1. So, the same idea here would be the unknown point y on n line minus the known point out of x minus -1 is equal to m2, which m2 is 1. So y minus 2 out of x plus 1 is equal to 1. Y minus 2 is equal to x plus 1. Y minus x is equal to 3. If one wanted to use the other technique I've mentioned to Swale, y is mx plus c. Since I have m, I'll have y is equal to 1x plus c. To find c, substitute -1, 2. You'll get 2 is equal to -1 plus c. And you'll see that c is 3. Then substitute here m and c, you'll have y is equal to 1x plus 3, which y is equal to x plus 3, which is the same answer as this one. Yes, Monica Namagem, what are you trying to write?
I'm sorry, that was an accident.
Okay, any other questions, guys? Time is up. Allow me to stop here. Follow me on YouTube. Follow my TikTok account, Hamza Luwama 01. I think I'm the one, but 0 something. In case of anything, I always post there some videos I do make in my free time, so try to follow them up. I'll definitely follow up with this coordinate geometry so that I finish it, so that you can be able to enjoy it also in one way or the other. Any further questions, always inbox me on my WhatsApp line so that I can be of help. Otherwise, we have a very good morning.